All right, without actually naming it, we actually have already been working with the idea of the instantaneous rate of change. And so we've been talking about the derivative, using the definition derivative and the derivative of f of x at a certain point. And you've been using already the limit as h approaches 0 of f of a plus h minus f of a divided by h. We've been working with this. However, I just want to show you how do you find the derivative at a point. So this will be the actual m of the tangent line. And so let's go ahead and hop in. So number one, what is the instantaneous rate of change at x equals 2 of the function f of x is equal to negative x squared plus 2x? So the first thing we want to do is we want to go ahead and use our derivative rules. And so we have f of x is equal to negative x squared plus 2x. And so my f prime of x, my derivative, is going to be equal to negative 2x plus 2. And so instead, now that I have my derivative formula, I can go ahead and plug in f prime of 2. And so I get negative 2 times 2 plus 2, and that will give me negative 4 plus 2, which is equal to negative 2. At time t seconds after it is thrown up in the air, the position of an orange is given by s of t is equal to negative 4.9 t squared plus 25t plus 3 feet. Given find s prime of 4 and interpret the meaning in the context of the problem. So I have an orange that's getting thrown up in the air and coming back down. So let's go ahead and find our derivative. So s prime of t is equal to negative 9.8 t plus 25. So that means my s prime of 4 is equal to negative 9.8 times 4 plus 25, which is equal to negative 14.2. So let's go ahead and see if we can find meaning in this. So if it's negative and it's a ball, an orange being thrown up in the air and it's not coming back down, if it's negative, that means my orange is falling. And so this is a rate of change. So the orange is falling. I know it's falling because it's negative at a rate of 14.2 feet per second. Number 3, we're going to use the calculator to find f prime of 4 over pi for the function f of x is equal to 3x squared plus 7x plus 1. So if you're allowed to use the calculator, there's no point in just finding the derivative and then plugging in. Let's go ahead and use the calculator features. So I know this looks kind of small, but this is the best I can get with getting a TI calculator on the screen. So what I want you to do is I want you to go to Math, which is underneath your alpha button, and I want you to scroll down all the way through to where you see NDeriv, number 8, and I want you to go ahead and hit enter. And the way this is a function on your calculator that allows the calculator to find the derivative at a certain point for you. And the way the input works is, first we have to put in your function. So we're going to do 3x squared plus 7x plus 1. And then next to the parentheses, you'll notice you have a comma, and then you need to let the calculator know what your variable is. And so we're going to do comma x. So that lets the calculator, so the first input is the function, the second input after the comma is what is the independent variable. Finally, the calculator wants to know at what point, so that's what we're going to do at 4 divided by pi. Divided by pi. And then we're going to hit close parenthesis. And so we're going to allow the calculator to do the work for us. And so we get 14.639. And so typically when you use your calculator, it's probably going to be on a multiple choice. And so if you're going to have that, you can just go ahead and write, just circle the 14.639 14.639. If it is free response, so you would just write f prime of 4 divided by pi is equal to 14.639. And so we would just go ahead and write, if this was a free response, we would just go ahead and write f prime of 4 over pi is equal to 14.639. And that's all you had to show. All right, a lot of times they'll allow you, the first one was pretty easy with a simple polynomial, but a lot of times if they're having you use a calculator, they're going to give you some sort of monstrosity, which I've given you here. You have to be careful because when they're talking about the derivative, make sure you plug in, use your parentheses appropriately. I'll show you when I use my calculator. You also, if you want to know the value, sometimes they give you the value. They'll put this little line. You'll see it, this little line here. That means an evaluation line. We're going to really get into that when we talk about integration. And I put a red box because it tells me I want to find, so I want you to evaluate. That's what that line means. Evaluate or plug in where x is equal to e. And so we're actually going to use a calculator, and we're going to use the end derivative function again to find that. All right, so let's go ahead and go back to math, and we're going to go down to, again, to 8, math 8. And if you just want to do math 8, enter, that's fine. That'll work. And so we want to get the end derivative function, and so we're going to do, I'm going to go ahead and do x to the 2/3. Yes, you can use the cube root function if you'd like. You don't have to. And already I'm kind of screwing up a little bit because I forgot to do my parentheses. So I'm going to do second insert parenthesis, and because I want this whole thing to be multiplied. And then I'll do plus x squared, close parenthesis. I'm multiplying that by 1 divided by parentheses x to the 4th, close parentheses. Whoops, forgot my caret. Plus x. And I want to divide that whole thing by x to the 6th. So x caret 6, close parentheses. And so now I just wanted to go ahead and do comma x, comma, in this case we're going to do second e. Close parentheses and hit enter. Hopefully I didn't screw that up. Okay, good. So the program ran, so I didn't have any issues with parentheses. So again, this probably would be a multiple choice question, and you would circle negative 0.00 or negative 0.077. Okay. Finally, number 5, if f is a differentiable function, then f prime of a, this is a definition, is given by which of the following? As x approaches h of f of a plus h divided by, or minus f of a divided by h. Is it number 2, limit as x approaches a of f of x minus f of a over x minus a? Or finally, the limit as x approaches a of f of x plus h minus f of x divided by h. And so to help you out, you want to find the one that if I plug in that value, am I going to get a 0 in the denominator? So if I look at Roman numeral number 1, if I plug in h in for x, I'm just going to have, it's not going to get me a 0 in the denominator. My h is already there. Now if h was going to 0, this would have been correct. But right now, at this point, it's not. I'm just going to have f of 2h minus f of a, which I'm not really sure what that's going to do. I don't really have any. I don't even have x's even to plug into. So number 1 is incorrect. Roman numeral number 2, as x approaches a, if I plug in a in for x in the denominator, I get that nice 0. Same is true if I plug in a in for f of x on the top and I subtract it from f of a, I'm going to get 0, 0. So For sure, Roman numeral 2 is what I want because that gives me that 0 over 0, that indeterminate form that we've been working with. So we for sure want number 2. Number 3, as x approaches a. So I would have, if I plug in a in for x, I would have f of a plus h minus f of a divided by h. But again, I'm not going to have a 0 over 0 situation, so it can't be Roman numeral number 3. So the answer is B, Roman numeral 2 only.